Hi, Al Williams here. Another quick and dirty video for the 1802. In this particular case, I've got the 1802 Pico, which is emulated, or actually 1802 Black on a Pico, or a Raspberry Pi Pico. Sorry, told you this would be quick and dirty. And I wanted to show you what I've done with the Metamonitor. The Metamonitor actually isn't 1802 code, but it has control of the simulation of the 1802 code, and so it lets you debug at sort of a level beyond what a normal 1802 debugger would do. So I am in the home demo directory, and I've already prepared a little assembly file. Starts at 2000 hex, puts 10 in the C register. Really didn't have to put the high number in there, but I did. The assembler doesn't like labels all by itself, so I put a no op on that loop, even though I should have just put it down on the next line. Then I make a subroutine call into the BIOS to print 1802 with a carriage return. I decrement the C register, take a look at the low byte, and if it's not 0, I go do it again. Otherwise, I return to the operating system. So this is going to load at 2000, but if you look at the Metamonitor, it loads at 7,000. And the reason for that is just for this reason, so I can do what I'm about to do is load demo. Okay, and then I can run Metamon, and since it's going to load up at 7,000, it'll be way out of the way of this program, and that will allow me to debug it. So you can see the Metamonitor now knows about a VT100 screen. You need to have 24 lines of 80 characters set up, or it won't work well. So if you're in a small window, you can be in a bigger window and it tries to accommodate that, but the right thing to do is just have it on a proper terminal. Now, if you don't like this, you can see on the prompt, V will toggle this and it'll go back to the old way, which is just a pretty much standard TTY interface. And the screen's broken up into three parts. The top part has the registers. The middle part has the output of whatever commands have a lot of output. And then there's a couple of pieces of disassembly there, including the little arrow shows you where you're about to run. So let's do this. Let's set R3 to 2000, which is the start of our program. So you can see the disassembly changed in there. And if you wanted to look at the memory at 2000, you could do something like this. And you can't specify how many bytes. It's always going to fill in that middle window. So even though on the other style of using this, you could say, well, I want to look at 10 bytes here, or I want to look at 200 bytes here, you can only look at that little bitty window, which is still, 128 bytes. It's not bad. If you wanted to disassemble that to say, see what's beyond 2003, you can do that too. And you can ask for, whoops, I'm sorry, I always do that. You can ask for help. Just to give you a quick rundown, the register command here isn't that useful just by itself because the registers are always shown up there. But you can look at a specific register. I don't know what good that does you, but just like I set R3, you can use that to set registers. Memory, we've seen that. Go will cause it to execute. We can set breakpoints, single step, which is next. We can read input and output ports. You can do an exit or a continue, both of which will try to go ahead and continue executing until something runs out. You can send front panel commands with that dot command. I've left that in there. Probably need to take that out of the 1802 PC one because this is for the eventual return of the 1802 Uno hardware, which I'm working on slowly but surely. We've seen the disassemble command, exit to OS. That needs to come out of this one. There is no OS on the Pi Pico, so I need to make that change. I thought I had, but I think I copy and pasted. You can get into the disk menu. You can toggle the visual. If the screen's corrupted, you can hit S and hit enter. That'll just redraw everything, does a status refresh. So a lot of different things you can do. So let's look at that program running. I'm going to go ahead and hit N for next, and then put IRC, O10. So you can see the accumulator is changing here, and it's also changing here. and R3 is changing, and RC is changing. Um, so when we put low, right now RC is 2. When we do the next, now it's 10 of A hex. This next piece, it looks weird because there's this BQ, and I see I have another bug I need to fix there, but the BQ is not really there. It's because this call reads 1802 exclamation point, and so that's just the DB line after there, and that's just the random instructions. So let's do a little better than that. Let's do a disassemble at 2007, and we don't like that, so I'm going to do 2010. And you can see there's the 0 at 2011. That's the end of the string. So I'm going to set my breakpoint 1 at 2012 because I don't want to step through the BIOS call. And I can take a look at that, and you can see I've earlier did this, so now I have 2 breakpoints there. No problem. I could say breakpoint 0 minus, for example, and now that's disabled. So that's pretty easy. So what I'm going to do now is I'm going to tell it to continue, and that's going to run that BIOS call. Now, here's a little problem. So it was supposed to print 1802, did it? Well, yes, it did, but the visual full screen just wiped it out. So, you know, if you had eagle eye vision, maybe you could have seen it whiz by. But I'll come back to that. So we'll say decrement RC, and sure enough, RC went to 9. We're going to get low RC, and we're going to branch to 6. And so once again, now we're back at the top at that no op. But if I really wanted to see it print and didn't want to just take it on faith, I can get out of full screen mode and I can say continue. And there's my 1802, and I got a break, and I'm back in the normal mode. And I could stay in that normal mode all I want, right? So we could take a look if you wanted to look at what's in RC now, that's 7. If you wanted to look at all the registers, so you can do all the same commands. But what you probably want to do is go back to visual and tell it to continue a few more times, and we can see there's the last one, and we returned back to the OS. So it's pretty useful. There's a couple little rough edges. I'm sure I'm going to find more of them as I work with it and as you work with it. But overall, it's fairly useful. This works on 1802 Black or 1802 PC. It does require a VT100 terminal. It really does need to be kind of sized correctly, or it's not going to look good. If it doesn't look good and you don't want to resize your terminal, just exit out of visual mode. You can compile it so visual mode is not the default, but by default it's always going to come up in the visual mode first. And of course that works from the BIOS. We did it from the operating system, but it works either way. As however you get into the monitor, it works in visual mode. So anyway, hope somebody enjoys that, and thanks for watching.